Welcome back and welcome to Section 7, Maintaining ACID Compliance with DynamoDB Transactions. Welcome to Video 1. What is ACID and why is it difficult to achieve in a distributed system like Dynamo? Well, firstly, I guess we need to take a step back and understand what ACID is. So ACID is really all about ensuring the consistency of data. And it's something that you kind of take for granted because it comes pretty much for free in most traditional relational database models. But with distributed systems like DynamoDB, you don't really tend to find that they're ACID compliant. And most NoSQL databases are distributed and therefore don't tend to be ACID compliant. So what does ACID mean? Well, the A stands for atomicity. So that means transactions are either all or nothing. So you can never end up in a situation where part of your transaction succeeds. So if we think about like an airline booking system or a hotel booking system, for example, it's no good if the booking goes through, but they forget to take your payment data because that part of the transaction fails. Or if you're booking tickets for a concert, they might end up overselling their tickets because the part of the system that deducts tickets from the ticket availability table, a transaction there failed. Another part of the transaction succeeded and it told you that the booking had gone through, but actually it hadn't. So, that's what atomicity means. Consistency means only valid data is saved. So what that means is every time a transaction is acknowledged, it means as soon as another transaction comes along to read it, the response shows the whole result of that transaction and never a partial result of that transaction. And isolation kind of ties into that. So it means that no two transactions can interfere with each other. So you can't end up with a transaction updating another transaction's data while the first transaction is in flight. And the last thing is durability. So what that means is once a data is written, it will not be lost. So as soon as the database has acknowledged the right operation, it's safely stored and persistently stored. So with ACID, really everything revolves around transactions. So a transaction is a collection of read or write operations that succeed only if all other operations in the transaction succeed. And if any of those single operations fail, all preceding operations in the transaction will be rolled back. And we can see an example of that here in this diagram. So the first transaction, all of these three operations, 1 to n operations occur, they all succeed, and then there's a commit, and that makes those transaction operations available to other operations. Whereas on the one on the right, the second operation fails, so nothing gets committed. And that allows concurrent transactions to be isolated from one another. And if you combine all of these things together, it means a database is able to offer ACID guarantees. So how does this work? Well, when you start a transaction, the database engine will need to create locks on the records that you're about to modify in that transaction. And this is to ensure that other operations don't attempt to change them while your transaction is executing. The database will then attempt to apply each step of the transaction in a way that's only visible to you. And that's important because you don't want other transactions to see the effect of partially committed changes, because that would break the consistency rule from ACID. Now, if any of the steps in your transaction fails, all previous steps will be discarded or rolled back. And at the end of the transaction, there's a commit statement. At that point, all changes in your transaction are committed atomically. So that means they all go through at the same time. And everything in that transaction then immediately becomes available to other operations and other transactions. Now, all of this is usually possible because all data resides on a single server. But DynamoDB is distributed. Data doesn't reside on a single server. In fact, it resides on many, many servers. So that means we need a more complicated protocol for performing commits. So in a relational database, if we have multiple shards or multiple database engines, we perform what's called a three-phase commit. Now, Amazon haven't released how they've implemented transactions in DynamoDB, but it's very likely it follows something based on the 3PC protocol. So the way the three-phase commit works is that the database engine has to elect a coordinator node, and the coordinator node is responsible for making sure that the operation goes through successfully. So the first thing it will do is it will ask all participants if it can commit. So this is after the transaction steps have been applied. It'll ask them all if it can commit. If any of them don't respond, that's counted as a no. So a timeout causes the transaction to abort. The next thing it will do, the coordinator will send a commit authorized message. So there'll be a pre-commit message and all participants will then have to respond to say yes, they're prepared to commit the change. And again, a timeout causes it to fail. And the last step is the coordinator will ask or will tell all nodes to actually go ahead and commit, and they should all respond to say that they have committed. So that's the 3 phase. You have the can commit, the pre-commit, and the do commit. Now, a couple of notes about transactions in DynamoDB. A transaction can contain up to 10 operations in any combination of get, put, update, delete, or condition check. If any object in a transaction is being modified while the transaction is in progress, the transaction will fail. And that's really, really key. So lots of relational database systems will lock items that are being modified in a transaction. So if anything else tries to modify them, they get queued up. But what happens here is DynamoDB doesn't lock the item, but it means that if somebody goes to update that item while the transaction is in progress, the transaction will fail. Now, you can target multiple items in multiple tables, which is a really, really cool feature, as long as they're in the same region and the same account. But no actions in a transaction can target the same item. So, for example, you can't condition check and update the same item. So that's everything for this video.